Alright, so today we're going to talk about rational functions. And specifically, we're looking at finding points of discontinuity through asymptotes as well as graphing rational functions. So, the first thing we're going to look at the definitions of a vertical and horizontal asymptotes. Now, before I define these for you, all an asymptote really is, it's really like an imaginary line that the graph of a function can't touch. It will get closer and closer to that line, but it will never actually touch the line. So, first, we're going to define the line x equals a. A is just any number, any value. It's a vertical asymptote of the graph of a function f when f of x approaches infinity or negative infinity as x approaches a from the left side or the right side. And the line y equals b is a horizontal asymptote of the graph of a function f when f of x approaches b as x approaches infinity or negative infinity. So there is also a process for finding these asymptotes. And we're going to put that on our next page. So to find vertical and horizontal asymptotes, we need to first say something. We need to let f be a rational function. Now, all a rational function is say we have f of x we're going to let it equal one function that we'll call n of x, and it's being divided by another function that we'll call d of x. And it's going to equal something very interesting looking. It's going to equal some polynomial that we can write as an x to the n plus an minus 1 x to the n minus 1 plus some more terms that will lead up to a1 times x plus a0, and that's going to be divided by bm x to the m plus bm minus 1 x to the m minus 1 plus some more terms that would lead to b1 times x plus b0. Now there's a couple conditions we have to add to this. We have to say that this happens where n of x and d of x have no common factors. If they do, those factors are not considered part of any asymptotes. So, here's what we can say next. The graph of f has vertical asymptotes at the zeros of d of x. So we're going to look for what values of x would make the denominator equal to 0. If we have any of those, then those are vertical asymptotes. The next thing we can say is the graph of f has at most one horizontal asymptote, and we determine this by comparing the degrees of n of x and d of x. So we look at the highest degree of our numerator and the highest degree of our denominator. From there, what we can do is when n is less than m, so if the degree of our denominator is larger than the numerator, we say y equals 0 is the horizontal asymptote. When n is equal to m, so if the degrees are the same, the horizontal asymptote is equal to y equals a n divided by b m. That would be our horizontal asymptote. And finally, there's one last case. When n is greater than m. If that is the case, there is no horizontal asymptote. So let's look at an example where we have to find any vertical and horizontal asymptotes of a rational function. So our first example, we're going to find the horizontal and vertical asymptotes of a, we're going to have f of x equals 2x squared over x squared minus 1. Now, for vertical asymptote, I'm just going to abbreviate it VA. We need to find, for the vertical asymptote, what values of our denominator, what values of x squared minus 1, what values for x would make 0. So what we're going to do is set it equal to 0 and solve it. And we've got a whole bunch of different ways we've learned on how to do that. In this one, what I'm going to do, I'm going to add 1 to each side, have x squared equals 1, and then take the square root. So I'm going to find that x equals plus and minus 1, which means we've got two vertical asymptotes. We've got x equals 1 and x equals negative 1 for our vertical asymptotes. Our horizontal asymptote, which I'll abbreviate as HA, remember we have to look at the degree of our numerator and denominator. So what we're going to do is we're going to look at the term with the highest exponent, we've got 2x squared, and then we've also got just x squared. So we're looking at that term for both the numerator and denominator. We have to ask ourselves, that power that we're raising the exponent to, are they equal? Is one bigger than the other? And if one's bigger than the other, what case do we look at? And I look at this and I see both x's are raised to the power of 2, which means they're equal. So when we look at our table you just wrote down in your notes, we're going to have the horizontal asymptote is going to be y equals an, which is 2, over bm, which is 1. 2 over 1 gives us y equals 2 for our horizontal asymptote. Now, let's look at one other example before we move on. We're going to look at the function f of x equals x squared plus x minus 2 over x squared minus x minus 6. There's a couple things I'm going to do. If I want to find my horizontal asymptote first, and that's what I think I'm going to do, I am going to look at that leading coefficient. So, or leading term. We've got an x squared and another x squared, which means our horizontal asymptote is going to be y equals 1 over 1. So our line for our horizontal asymptote is just going to be y equals 1. Now let's do the vertical asymptote. Now, we do have to make sure there's no common factors. So to do this, we need to actually factor our numerator and our denominator. So if I factor my numerator, I need to know what numbers multiply to make negative 2 that add to make a positive 1. Well, I can only think of a plus 2 and a minus 1. So I've got my factors for my numerator done. Now I also have to factor the denominator, and I need to make sure that my numerator and denominator don't have a common factor. So now I have to ask myself, what questions multiply to make negative 6 that also add to make negative 1? Well, I know 1 and 6 multiply to make 6, but I can't think of a way to add them to make 1. I also know, though, that 2 and 3 multiply to make 6. And if I made one of them positive and the other negative, I could make 1. And I want a negative 1, so my negative is going to go with the 3. My plus is going to go with the 2. Now I do notice something. My numerator and denominator have a common factor. I have to eliminate that common factor because that is not going to be a vertical asymptote. That's just going to be a hole in our graph. Just a spot where in the graph we don't have a y value. So our function, we can rewrite it as x minus 1 over x minus 3, but we still have to acknowledge that x can't equal negative 2 from the x plus 2. Now to find my vertical asymptote, I'm going to take that x minus 3, and I'm going to set it equal to 0. If I have that, and solve for x by adding 3, we're going to find x equals 3. That is our vertical asymptote. So, I think that's actually going to wrap up this video, and in our next video, we're going to look at guidelines for graphing rational functions, and then an example on how to graph a rational function.